In this video, we're going to do a bunch of problems involving solving exponential and logarithmic equations. For this first problem, what we're supposed to do is recognize that on the left side of the equation we have a base of 3, and on the right side of the equation we have 81, which can be written as a base of 3. To be more specific, we can write 81 as 3 to the 4th power. Now that we have the same base on both sides of the equation, there are no coefficients on either side of the equation in front of that exponential expression, then what we can do is just consider getting rid of the base of 3 on both sides of the equation. That leaves us with a pretty simple equation, 3x minus 7 equals 4, which we can solve pretty quickly by adding 7 to both sides and dividing 3 from both sides. Now this trick of getting the same base on either side of the exponential equation works in very few cases. So I'm going to show you a more general way to solve exponential equations using this same problem. And in general, when we have an exponential equation, one step that we're going to do to solve it is going to be to take a logarithm of both sides. So we can just write log in front of the left side of the equation and also in front of the right side of the equation. And while we can really use any base to solve this equation, it probably makes the most sense to use a log base 3 because 3 is the base of our exponential equation. Then as we discussed in class, this is a composition of a logarithmic function and an exponential function with the same base. They can cancel each other out, and we're simply left with 3x minus 7 on the left-hand side. On the right-hand side, we have a log base 3 of 81. Now you could use your calculator to get this number, or you could recognize that the power on 3 that would give you 81 is, in fact, 4. This gives us the same equation that we had a couple steps above, and we end up solving for x and getting 11/3 for our answer. So either way we do this problem, I'm getting 11/3. Good. Now let's take a look at problem number 3 and do this one a couple of ways as well. One way to do this problem is to recognize that every single base in this problem can be converted into a base of 2. For example, I can replace this 4 by 2 squared. I'll just copy down the second term, and we can write 16 as 2 to the 4th power. Now that every single base and every single exponential expression in this equation is the same, we can use our rules for exponents to finish the problem. So on the left here we have 2 squared, and that's also raised to the x squared power. The rule for exponents is if you have an exponent on an exponent, you can multiply those two exponents. Now we have two bases that are the same with two different exponents, and those two terms are being multiplied. So the exponent rule here is we can actually add those exponents together. Okay, now that we have on each side of the equation a pretty simple exponential expression, and each of these exponential expressions have the same base, we can get rid of those bases and just set the two exponents equal to each other. Alright, so this gives us a quadratic equation, and typically the best way to solve a quadratic equation is to get everything on one side, set it equal to 0. At this point, if you can factor, great, then factor. If you're not sure how to factor this problem, you can always use the quadratic formula. But this trinomial does factor into two binomials, just like this, no matter how you do it. And then we can split this problem into its two pieces. This piece over here is going to give us an answer of x equals -4. This piece here is eventually going to give us an answer of x equals 1/2. And that is it. But as is almost always the case with these problems, we can do this a totally different way. And I actually think I like this second technique a little bit better. What we're going to do is recognize that this is an exponential equation and take a log of both sides. Now we can take a log of any base of both sides of this thing, but we might recognize that all these things can be written as a base 2, so it's going to make the most sense to use a log base 2 in this problem. Now on the left side of the equation, we recognize that we have two terms inside of a logarithm that are multiplied, and we have a property for logarithms that says that we can split that up into two pieces and add those two pieces together. That is called the product rule. Next, we can recognize that inside of each of our logarithms on the left side, we have our term with an exponent on it, and we can use what's called the power rule to take each of those exponents and move them out to become the coefficients of our logarithm. Now we have a log base 2 of 4, and we know that a log base 2 of 4 is 2. So this first term is x squared times 2. Next we have a log base 2 of 2, and we know that that is 1. And on the right hand side of the equation we have a log base 2 of 16, and we know that that is 4. And at this point we are back to the quadratic equation that we came up with in the first way to do this problem. So if we want to finish this thing up, you just go back to the previous problem, you look at those last couple of steps, and they'll be exactly the same. So I'm going to enter our answers of 1/2 and -4. Good job. Let's do the next problem in the next video.